Hi everyone. So here I continue on topic 29. Um, so we just start topic 29. It's integral or antiderivative. So at the beginning I can give you just an introduction. So differential equations or differential calculus so are just the process that you find a slope of tangent line, and we talked about that. Okay, so we started with a slope of tangent line, and we knew that we had to do by a limit, and the limit was 0/0, and then we just worked around it, and then we just defined that's derivative of the function. So the process of integration is just finding the area under the curve. So if I do integration, if I do derivative, I'm finding a slope of tangent line, which is here. But when I find integral, I am finding area under the curve. So I'm finding this part. Okay, so derivative that we did before, as I said, so we did it because of a slope of tangent line, and now we are going to introduce integral, so which is useful for area under the curve. Okay, and then we say differentiation and integration, they are both opposite of each other. Okay, sometimes instead of integral we say antiderivative. So derivative and antiderivative, so they are reverse of each other. Okay, so right now we are going to do just the opposite. So before I used to give you a function, and so function fx. Okay, I give you the function fx, and you had to give me this guy, which was derivative of that. Okay, and now I am going to give you this guy, the lowercase f, and I want you to find the other one. So means opposite. So I'm going to do opposite. So I have the derivative and I want the original function. So this is the main lesson. Okay, and the reason we knew derivative because of slope of tangent line, and the reason we need antiderivative is just area under the curve. So I want to find area under the curve. So for some curves, so it's very easy to calculate what is area under the curve, but for some no. So you need to know integral. Okay, here I start with something easy. So I tell you what is antiderivative of x cubed. Remember, I want a function that if I find derivative of the function, the result is x cubed. So you all know that derivative of x power n is nx power n minus 1. So you would say, okay, so there, when I find derivative, I have to reduce the power. So maybe here I have to add the power. And then you say, I think antiderivative of this is this. Then I tell you, okay, so if you think it's right, then if I find derivative of that, I should have the answer. I should have the original function. And then I say, okay, no, it's this. So then you would say, okay, I made a mistake. I would say, okay, antiderivative of this is x power 4 divided by 4. Okay, then I would say, okay, if I find this, it is this, and perfect, this is correct. Then I ask you, how about if you find the derivative of this one, x power 4 divided by 4 plus 1? What is the derivative of that? You say derivative of 1 is 0, so it doesn't make any change. So derivative is this guy. So I would say, how about if I change 1 to 2? How about if I change 1 to 10? How about if I change 1 to c? So you would say all fine. So because derivative of a constant number is 0. So I tell you, you have to, in order to be in a general case and in order to include all the answers, when I ask for antiderivative of antiderivative of this, you have to tell me this plus c. Because when I find derivative of that, derivative of right side, I see its derivative of this plus derivative of this, which is this, which is this. Perfect. So I went to my original function. Okay? So just to make it easy for you, when you want to find antiderivative of a function, you have to find the answer whose derivative is just what you have from beginning. So see, I asked for antiderivative of this, and I told you the answer is this one. How can I make sure that the answer is this? So I find derivative of right side, and I see I can reach to this side, left side. So when you do antiderivative, if you do derivative of the answer, you should go to the original function. Okay? So here I would say n times, here I have to say divided by n. Here I reduce 1, here I have to add 1. And at the end I have to do plus c, because derivative of c is 0, and in this case I can include all the answers. So therefore I have infinity number of answers. Okay? So in order to make it just easy for you, I change antiderivative that I write every time, I change it to this sign. So I can use this sign. This sign is coming with this dx as well. And it says you are finding antiderivative respect to x. The same as when I say dy over dx means derivative respect to x. Okay? So here I can say antiderivative or integral, both are the same. So I say integral of x cubed dx. Remember, these two comes together. Okay? They're coming together. I cannot separate them. So this symbol is antiderivative, and dx is coming with it because it's agreement that we do respect to which variable. I have to show respect to what. It's exactly like dy over dx, but there I wanted to make it easier for you, so I said instead of dy over dx, use y prime. So when I say this, you tell me the answer is, for derivative I reduce, here I have to add, for derivative I times with n, here I have to divide, and I have to do plus c, because derivative of a constant number is 0, and c is a constant number. Okay? So now I can go to this formula. What is integral of 0? Just c. Because I know derivative of c is also 0. What is integral of 1? X plus c. Because x plus c, derivative is 1. How about this? Here, derivative of this is a. Here, derivative of that is, if I find derivative of this, derivative is n plus 1 x n divided by n plus 1 plus 0, which is x power n. See, I reached to the same thing I had. Look at this, the same thing, the same thing, the same thing, and the same thing. Okay? How about if I have a beside? How about if I have a number beside? The same as in the derivative that I have to carry that number over, now I have to carry it here as well. How about ln? I know derivative of ln is 1 over x. Okay? So now integral of 1 over x is that. How about e? For e, the same as before, integral and antiderivative and derivative the same. Sine and cosine we didn't cover, so I have to remove it. How about if I have plus and minus, the same as before, I can distribute integral. But remember, it doesn't work for multiplication. No for division. Okay? If I have integral fx gx dx is not integral f dx integral g dx. No. It doesn't work that way. If I have integral f divided by g, it's not integral top divided by integral bottom. Okay? Here I didn't include x, just to make it. We all know it's coming by x. Okay? So now what should I do to just answer all questions this way? So I have to work on this formula. Okay? You need to know this. You need to know this number 1, number 2, number 3, number 4, number 5. You need to know number 6. You need to know number 7. And you need to know number 10. Okay? You need to know all of those. So here I am going to do examples and also talk about those things. Okay? So here, find integral of this. Okay? Here it's just explaining in terms of d, so dy over dx, it doesn't matter. So here I can say this way, okay? I have dy over dx. So first I do dy equal 3x squared dx, okay? Then I do integral of both sides. So integral dy equal integral 3x squared dx. Integral left side is based on y, so I do y. Integral right side is based on x, so I do this divided plus c. So y is x cubed plus c. Okay? So you don't need to. So I'm just, instead of this, I'm just going to say y prime is 3x squared. And I want you to find y. And you have to do y equal integral this guy respect to x plus c. Remember, these two are coming together. Okay? So, right now, from now, I am going to give you a function and I want you to find integral of it. Means you have to find a function whose derivative is the original function that you have. So I'm going to do it step by step here. What did I say in part 10? In part 10, I said when you have plus and minus, you can just distribute, okay? But doesn't work for multiplication and division. Okay? Look at this. Okay, plus. Yes, I can do this. 5 x squared dx plus integral of 4 this. Remember, if I add 2 of these, I have to add dx as well. Equal. Step by step. But how about 5? Okay, look at this. I go here and I say, okay, look at this. See, a comes out, okay? So I have a number beside, doesn't matter, I can bring it out. Okay, 5 integral x squared dx plus 4 integral x cubed dx. How about next? Equal 5. How about this? Okay, I can write it here. Integral x power n dx is x power n plus 1 divided by n plus 1 plus c. Okay? So, remember, for derivative I reduce, here I have to add. For derivative I multiply with n, here I have to divide with n plus 1. Okay? And I have to add plus c because derivative of c is 0. Okay? So now, it's 5 divided by 3x cubed. plus 4 divided by 4x power 4 plus c. Simplify. 5 divided by 3x cubed plus x power 4 plus c. Right? I do it step by step. Okay, so how about this function? How about this one? Okay, so first I can separate it because it's plus. Okay, step by step. So I do equal dx over x squared plus integral 7x power this. Step by step. Integral doesn't go for division. What should I do? It's 1 over x squared. What should I do? Oh, okay, I can bring it up and change the sign to negative. Oh, perfect. Can I bring 7 out? Yes. 7 is a number. Remember, you just can bring the coefficient, which is a number, out, not x, for example. No. Okay, so this. Okay, now can I find the answer here? Yes. X power minus 2 plus 1 divided by minus 2 plus 1 plus 7. X power 3 over 2 plus 1 over 3 over 2 plus 1 plus c. Okay? Which is the same as here. Look at this. Look at this one. See? Here you have this, which you have to do x power 2 plus 1 divided by 2 plus 1. And for this, you have to do x power 3 plus 1 divided by 3 plus 1. And then I simplify. Okay? So, step by step. Then I can simplify. Okay, so I have x power minus 1 divided by minus 1 plus 7x power 5 over 2 divided by 5 over 2 plus c, which is minus 1 over x plus 14 over 5 x power this plus c. Okay, so 3 over 2 plus 2 over 2, which is 5 over 2, and then you have this guy. Okay, so done. I'm done here. You don't need to go further. So simplify before integration. Why? For this function that I give you, you look at there and say, I know I cannot say integral this times integral this. I can't. I don't have that. I told you it doesn't work for multiplication and division. So what should I do? In this case, you can expand. Okay, so it is integral, simplify before integration. Integral 4x power 4 plus 20x squared plus 25 dx. And then I can separate. 4x power 4 dx plus integral of 20x squared dx plus integral of 25 dx. And then I do a step by step. I bring 4 out. dx. Okay, so first I expand and then I just do integration. It's plus, it's not a squared anymore, it's not multiplication anymore. I don't need to be worried about that. So I do this. Okay, so yeah, and then it is 4 x power 4 plus 1 divided by 4 plus 1 plus 20 x power 2 plus 1 divided by 2 plus 1 plus 25 just x, because derivative of x is 1. Okay, and I can say here I have x power 0. This one is x power 0, so I can say it is x power 0 plus 1 divided by 0 plus 1 and plus c. Don't forget c. If you forget c, means you are just showing me one answer, but you have infinity number of answers because c can have any number. So then I have to divide your mark between infinity parts, and when I divide a number between infinity parts, you get 0. Okay, I'm just kidding. If you forget c, I reduce half a mark. Okay, don't forget. C is a constant number. Oh, I have to continue to simplify. So 4 over 5 x power 5 plus 20 over 3 x power 3 plus 25x plus c. Do I need to continue? No, you don't need to continue. Don't make these numbers with a decimal. No, just keep it this way. Okay? So let me see if I didn't do any mistakes. So if I did, just tell me. How about this one? So I told you integral doesn't work for division. So it's not integral top divided by integral bottom. No, it doesn't work that way. Okay, what should I do then? Here I know what to do. Here I can do separate them. Integral 3x this divided by this plus this divided by this plus this divided by this. So in algebra, when you have something divided just one term, when you have something divided by just one monomial, you can separate them one by one. So you can say the first one divided, the second one divided, and the third one divided, and until end. So now it is simplified 3x squared plus 4x plus 5 dx. Simplified. Oh, perfect. So I don't need to be worried about anything because I just cancelled. X is cancelled. So now it is integral 3x squared dx. I'm doing a step-by-step integral 4x dx plus integral 5 dx. In the exam, if you jump steps from here, it's fine because we do so many practice. So I know you know it. Okay, show me, for example, you have to show me this part. You have to show me this part. You have to show me this part, but after here you just can just tell me the answer. Okay, so it's 3 over 3 x power 3 plus 4 over 2 x power 2 plus 5x plus c. Simplify. This is x cubed plus 2x squared plus 5x plus c. Okay, look at that. How can I say it's right? How can I say my answer is right? Okay, do derivative of this answer. What is derivative of the answer? Oops. What is derivative of that? Okay, 3x squared plus 4x plus 5. Okay, look at that. I have the same thing. So if I find derivative of the answer, I can see original function. This means I didn't make any mistake. And that's good. Okay, you can check your answer this way. Practice question. How about here? This is easy. You can separate them, right? So you separate them first. Integral 4 dx. Remember, you have integral symbol. You have to have dx. Minus integral 3x dx plus integral 2 over x squared dx minus integral 1 over x cubed dx plus this one divided by 16, 2 power 4. Now I find the answer. So But before that, I can do it this way. 3x power minus 1 dx plus 2x power minus 2 dx minus x power minus 3 dx plus 1 over 16 integral dx, which is, do it one by one, okay? So it is 4x minus 3 over 2, oh sorry, this is, okay, this is a good thing I want to show you here. See, you do 3x power minus 1 plus 1 divided by minus 1 plus 1. And what happened? It is 3x power 0 divided by 0. Wrong. Okay? I didn't mention there because I wanted to reach to one of this kind of example to show you. Okay? Look at this. When I go here, there, if I told you there, so you just don't pay attention, but here you can see here, if I, let me see if I have the, yeah, so here I have to add this, let me see, plus 1, yes, I have to add this and plus 1 here, okay, and I have to mention n is not minus 1, so it doesn't work for minus 1, okay, see, it doesn't work for minus 1 here. Look at this, see here, see, n cannot be minus 1 because otherwise you have divided by 0. How about n equal minus 1? N equal minus 1 is here, If I have x power minus 1, this is 1 over x, which is ln. Okay? Look at this. Here, n cannot be minus 1. I didn't say there because we don't see it when we don't just feel it in our example. Okay? So, now I can talk about it here. Okay? Oh, see? It doesn't work here. Right? So I have to remove this because we'll be divided by 0. And I have to remove this and I have to keep it the same way. Just I have to bring so just this, okay, so I have to bring 3 out. So I have this 3 integral dx over x plus 2 integral x power minus 2 dx minus this plus 1 over 16 integral dx. Okay, what did I do here? I did separately. Okay, so because I have addition subtraction, so I did integral 1 integral second and I just continued. Okay, then I have a number beside, I can bring it out. So first I did integral first minus integral second plus integral third minus integral third plus. Okay, then I can change divided by x, I can change it to negative power, but I don't do this for this one. For this one I don't do because this one, the formula doesn't work here. This one is ln x. Then I bring the number out beside and then I find the answer. So it is 4x minus 3 ln x plus 2x power minus 1 divided by minus 1 minus x power minus 2 divided by minus 2 plus 1 over 16x plus c. Another point, I don't need to say C1, C2, C3. I don't need to have C for each one. Let me see. This is going crazy. Okay, I don't need to have C for each one. So look at this. Here I have several. Here I have several. Here, C, I don't need. I don't need to have C1, C2 for each integral. No. because all c can be just one c. So you can add one c at the end. Okay? So if I want to summarize the lesson, here I am doing antiderivative or integral. Means I have the derivative and I want to find original function. If I find the answer and I find if I find the answer and I find the derivative of that, I reach to the function that I have. Okay? So before I used to say derivative of this is n times x power n minus 1. Here I have to add, and instead of multiple, here I have to divide by that number, the power 1. The power n plus 1, I have to divide by that. And I have to mention n is not minus 1, because otherwise it will be 0, divided by 0. Then we did it for one example, then I explained, then we saw these things. So we can use them. Remember here, again, I have to mention n cannot be minus 1. For n minus 1, this is the thing. This is for n minus 1. So integral 1 over x, which is integral x power minus 1, is ln x. Then I know I can distribute integral for plus and minus, but not for multiplication. If I have a number beside, I can bring it out, the same as derivative. And now I can use the formula. Okay, integral of x power n dx is x power n plus 1 divided by n plus 1 plus c. And n is not minus 1. For n equal minus 1, the answer is ln x. And now I do these examples. Okay, if I have in the denominator, I bring it up and change it to negative exponent. And then I can use my formula. See, look at here. Okay? Here it doesn't matter. Here I don't see anything in the denominator. Right? Yes. Okay. So here. How about here? Here I know integral doesn't go for multiplication. Integral doesn't go for division. So here I simplify. How? I use Pascal. And then I say, okay, integral first plus integral next. At the end, I just add 1c. I don't need c1 plus c2 plus c3. No, you don't need. Because all c can be 1c. Just one constant number. And I follow just all the rules here. How about here? Here, again, I say it doesn't work for division, so I divide 1 by 1. When I have just one monomial, I can divide with the denominator. 1 by 1. Remember, just 1. But if I have, it is crazy. Okay? Again here, I can go for plus and minus. Maybe, I don't know what's wrong. I can go for plus and minus. I can bring the number out. I can change the power to negative. But remember, don't do it for 1 over x. I didn't mention there because I wanted to reach to this answer. To this question. Okay? Look at this. Integral of dx over x. If I say integral of x power minus 1 dx, and I say x power minus 1 plus 1 divided by minus 1 plus 1, it is x power 0 divided by 0. Doesn't work. No, divided by 0. No. So for that, I say the answer is ln x plus c. Done. Because I know derivative of ln x is 1 over x. Okay? How about here? I remove it because we didn't do sine and cosine. Again, how about here? I don't do it. How about here? Yes, I can do this. What should I do? I have a number beside, I bring it out. Okay, so 2 integral e power x dx. What is the answer? Derivative of e power x is e power x, so integral of that the same. So it is 2e power x plus c. For c, you just can add c at the end. So you don't need to do 2c, for example. Okay? You don't need to say it is integral 2e power x dx, which is 2 integral e power x dx, which is 2 times e power x plus c, which is 2e power x plus 2c. You don't need. Instead of 2c, instead of c1 plus c2 plus c3, instead of several c, you can just write one c because that's a constant number. Addition of constant number. So you don't need. You don't need that. Okay? Let me see. Yeah, so again here, I don't need. Okay, I have to add more examples maybe from Wiley Plus because we removed those examples. And thank you so much for your attention. Let me know your questions and stay safe. Bye.